Welcome to the video for 2i more than one variable. So we're going to be looking at equations that have more than one variable in them. I will be able to solve literal equations for a given variable through the use of in-class notes and activities. Okay, so what is a literal equation? Where a literal equation is an equation with more than one variable. And you can't solve these for a number. If you have one equation with multiple variables, you cannot solve for a number. So we're going to see what we're going to do with this down below. You'll be solving for a given variable, so you'll be basically rewriting the equation so that way you have one variable by itself, but you're not going to get it down to a single number. All right, high definition TV screens come in different sizes. However, they all have the same proportions. If you divide the width of an HD TV screen by its height, the result is 16/9. If you label the height H and the width W, then every HD TV screen satisfies the two variable equation. W over H equals 16/9. So this is just a proportion, and you see it has two variables in it. So this alone, I could not solve for one of the variables. I couldn't find out what W is. I couldn't find out what H is. I could rewrite this equation so that I would have a formula to find out W or H if I'm given W or H. So, for instance, find the width of each screen for the given height. Okay, so we're given the height. So we're going to plug that in. But first, before we do that, we're going to solve for W, okay, because that's what we want this equation to do, is that I can plug in the H and I get out the W. So I'm going to cross multiply here, and I have 9 times W equals 16 times H, and now I'm going to divide by 9. And I get the equation W equals 16 H over 9. Okay, now all of these are height down here, so we're being given the height, and we're going to plug them into our equation to find the width, because we made this equation that's perfect for finding width. So my width equals 16. I'm going to take out the H and make a home for what I'm going to put in, over 9. And now I'm going to go ahead and plug in 18. Now I could get a calculator, or I can put 9 into one of these. Since these are being multiplied together, you only need to put 9 into one of them, not both of them. If we had addition or subtraction, if we had addition or subtraction in between these, then you would have to put them in both. But since they're being multiplied together, you can just put it into one, and it is correct. So I'm just going to do 18 divided by 9 is 2, and then 2 times 16 is 32. And so I didn't even need a calculator to figure this out. So my width for this TV would be 32 inches. All right, let's try it again for this one. Okay, so same equation. I'm going to plug in 36. And 36 divided by 9 is 4. So now I have 16 times 4. And if 16 times 2 was 32, well then times 2 again would be 64. 64 inches. Okay, last one here. W equals 16. Make a home. There you go. And I'm going to plug in 30. Okay, 9 does not go into 16 or 30, so now you might want to use your calculator, unless you can do this in your head. We know we're going to have a 0 on the end. 3 times 6 is 18. And then 3 plus 1 is 480. Divided by 9. And then let's leave this as a fraction, but because we're talking about the measurements of a TV screen, let's think about how we would probably actually use that. I'm going to say that this would be best as a mixed fraction. So 9 goes into 480 53 times. Goes in there, and it goes in there 53 times, and 9 times 53 is 477. So I subtract that up from 480, and I get 3 over 9. And now I have 53. and 1/3 inches, because this makes more sense in how we're using this. So you can see is once you put this into, once you solve for one of the letters, you don't have to do all this solving every time. All you have to do is actually plug in the number you have and find out the width. If you want to find, if you had a bunch of widths and you want to find the height, then you would solve this equation for height, and you'd already done the algebra here, and then you would just need to evaluate each time. Okay, so this is typically how we're going to do these, is we're just going to solve for one variable. So each of these equations have multiple variables in it, and then it tells you which variable to solve for. So in this first one, we're going to solve for y. I was trying to highlight it. So here we have a y here, and here we have a y here. Okay, so if you think back to when we were just solving equations with one variable, the same steps occur. Okay. First, we need to simplify, and then we go ahead and solve. So we need to simplify anytime there's the same variable in there multiple times. We need to simplify first. So first thing we do is we multiply or distribute anything. Well, that's not occurring right now. So then we're just going to combine like terms on the same side. That's not happening. And then we're going to go opposite side. So this guy needs to go to the opposite side here. So I'm going to subtract 3y from both sides, and I get 5y minus 13 equals 2x. Okay, the x can't be combined with anything. So now I just want to get everything away from that y. Okay, so this is what we're solving for. So that means I need to use backtracking now, because I've done all the simplifying I can to get the y by itself. So what's happening to y? It's y times 5 minus 13. So I'm going to add 13, and I'm left with 5y equals 2x plus 13. Then I need to divide by 5. And so now I have y equals 2x plus 13 all divided by 5. And you can leave it like this if you like, or you can separate it up into the two terms here. So we would have y equals, well, nothing can simplify with 2/5, so it would just be 2/5 x plus, and then we can divide this up 13/5. Both of these answers are totally right. All right, for this one, we're given the formula when we have Fahrenheit, how to convert it to Celsius. Well, what if we have Celsius and we want to convert it to Fahrenheit? For instance, we're traveling and all the weather reports are telling us the temperature in Celsius. We're going to want to change that into Fahrenheit. So what we're going to do is rearrange this equation so that way we have the f by itself. So I'm going to rewrite it because I need a little bit of extra room around the equation. So I have 5/9 times f minus 3/2. Okay, so the first thing that's happening, you need to check to make sure, there's the bell, sorry about the noise, you need to check to make sure that you don't have multiples of the same variable. So c's only in there once and f's only in there once. So that means all the simplifying has already occurred. So now I need to backtrack. So I have f times 3/2, or I'm sorry, f minus 3/2 times 5/9. So to backtrack, I want to divide by 5/9. And as I've explained in an earlier video, dividing by a fraction is just the same as multiplying by the reciprocal. So I'm just going to take this and multiply both sides by the reciprocal, and the reciprocal being just this flipped upside down. So 9/5. 9/5. Okay, don't overthink it over here. You did it just to cancel it out because this multiplied together is just going to be 1, and 1 times anything is just what it is. So we did that to cancel it out, and now we have it on the other side, 9/5 c equals f minus 32. Okay, last thing I need to do here is add this 32 to the other side, so I get 9/5 c plus 32 equals f. So now if someone gives me the Celsius, I can just put it in right there, multiply it times 9/5, and add 32 and find out what Fahrenheit is. Okay, here we have one with a whole bunch of letters, but it doesn't change anything. We're still just solving for y. Good morning, Pierre. So I'm just going to look and see what's happening to y here, and then backtrack. So I have y times b plus ax. So plus ax, and this is a positive ax, so I'm going to subtract ax from both sides. They cancel out here. Now I have by equals, I cannot combine these. So I'm just going to go c minus a x. And now lastly, I need to divide by b. So now I have y equals c minus a x all over b. Okay, coming down here, problems like D, so this one, we will come across a lot later. We will come across a lot later on. Put comma in there. So we're going to see these a lot, but they'll be with numbers. So now let's try solving them because you're going to really need to get good at this next unit. So let's go ahead and subtract 9x from this side. Because we're just solving, let me back up a little bit. We're just solving for y here. So I'm going to start by getting rid of this part. And now I have 3y equals, and I'm actually going to put these, I can't combine them, but I'm going to put the x term first. Okay, so I'm going to put it 9x plus 15. Okay, so you just put them next to each other, preferably with the x term first, and when we start graphing, we'll talk more about why that's important. And then we're going to divide by 3. Make sure you divide everything on this side by 3, not just one of them. And now I have y equals negative 9 divided by 3 would be negative 3x, and then 15 divided by 3 would be 5. There we go. Now, if you're familiar with slope-intercept form, you'll see that what we did was we put this in slope-intercept form. That's why I want to put the x term first. All right, same deal here. Subtract 2x. Subtract 2x. They cancel out here. I'm left with 4y equals, I'm going to put this term first, negative 2x plus 12. Then I'm going to divide both sides by 4. And I have y equals, well, negative 2 over 4 is going to be reduced to negative 1/2 x. And then 12 divided by 4 is just 3. All right, that's all of it. Go ahead and try these problems on your own so that we can check them in class. Thanks.